Hello friends, welcome back. Hearty welcome to you. Let us look at this problem related to determinants. We have to prove that of this matrix with the elements as b square plus c square, a square, b square, a square plus c square, b square, c square, a square plus b square equal to 4 into a square, b square, c square. There are so many ways of solving this problem, and in this video we are going to look into a new way of solving this video which is not covered mostly in lot of textbooks. So we will use one of the properties of determinants, that a matrix can be written as sum of two other matrices. So we'll try to make this matrix into two matrices, taking first column, dividing that into two parts. So in first column I'll divide that into b square plus c square, b square plus 0 and 0 plus c square, and we will expand the matrix into two parts by using this particular column. So our first step will be, from the first column I will pick b square and 0. Remaining two columns will be as it is. So third column will be same, a square, b square, a square plus b square. Now to this we have to add the second matrix. Now when we go to the second matrix, b square we have taken, so left out is c square, b square plus 0, so 0 is left out, 0 plus c square, so c square is left out, and remaining two columns will be as it is. Now you can see very clearly that from these two matrices we can take, from this column I can take b square common, and from this column we can take c square common. That's good news for us, because we will be getting ones. Once we get ones, we know how to get the zeros. We subtract the rows or columns as needed, we get the zeros. So once we get that, we can expand these two debts and we can sum them up. We should be able to get our answer. So let's go to the next step. In the next step we will take b square common. It will be 1, 1, 0, a square plus c square, here we have a square, b square, a square plus b square, and same thing in the second det, we can take c square common. We will have 1, 0, 1 for the first column, second column will remain as it is, and the third column also will remain as it is. So we will write down whatever we have as it is. Now our next idea is to make this value as 0 so that we can expand with this particular element. Similarly, make this element as value as 0 so that we can expand along with this particular element to find out the det. So to do that, we will write down what we want to do. We want to make R2 is assigned R2 minus R1, so that I can make second row first element as 0. Similarly here we will do R3 is assigned R3 minus R1. Let's go to the next step. When we go to the next step, this will be nothing but b square, and we will have, so 1 will be as it is, a square is as it is, a square is as it is, R2 is assigned R2 minus R1, so 1 minus 1 is 0. We are talking about this, 1 minus 1 is 0. Similarly here we get c square, here we get b square minus a square. So let's write down that. We will have 1 minus 1, 0, 0, a square plus c square minus a square is c square, and b square minus a square, and the last row will remain as it is, that is 0, c square and a square plus b square. Let's go to the next matrix. We will have c square common, then we will have first column as it is, first row as it is, that is 1 a square, second row also as it is, 0 a square plus c square b square. R3 is assigned R3 minus R1, that is 1 minus 1 c square minus a square plus b square minus a square. So let's write down that. We will have 1 minus 1 0, then c square minus a square. After that we will have a square plus b square minus a square, which is equal to b square. So in the next step we will be closing this problem. See how easy it is. So we'll do one more operation on this. We just expand the debts and simplify that. We'll be done with this particular problem. Let's move to the next step. Now we will expand these two matrices to find out the debt. Will expand along this particular element. So this row and this column is eliminated. We need to find out the debt of this 2 by 2 matrix. Similarly here we need to find out the debt of this 2 by 2 matrix. So let's write down that. We will have, that's equal to b square into 1 into, we'll just write down that matrix 2 by 2 debt, that is c square, b square minus a square, then we will have c square a square plus b square, that plus c square into, again we expand with first row first column element, first column a11 element. We will have another 2 by 2 matrix, a square plus c square b square, then c square minus a square and b square. Now we have to simplify this. So let's go to the next step. In the next step we will write down that's equal to b square into, let's put bracket, ad minus bc, that is c square into a square plus b square minus of c square into b square minus a square. Next we have c square into a square plus c square into b square minus c square minus a square into b square. Let's simplify that. If you see here, we can take c square common and we can take b square common here. So our next step will be, we'll write down b square, take c square common, what is left out is a square plus b square minus b square plus a square, and in the next step, in the next debt, we will take b square common, so it will become again b square c square into a square plus c square minus c square plus a square. Now simplify that. We will get b square cancelling it out here and c square cancelling it out here. So we will have b square c square into 2a square plus b square c square into 2a square, which is equal to 4a square b square c square. So that's another easier method how we can solve this problem, by taking the debt and writing it as sum of two other debts by using the properties of determinants. In this problem what we did, we took the first column, we divided that into two parts. One will have b square 0, another will have c square 0 c square. We have taken care in such a way that we can take b square c square common from the respective debt. We can get ones and zeros, so we can easily expand and we can find out the value of the debt. So please do let me know your feedback on this.